All right, we're going to be doing the properties of a wave. And I've drawn this wave here, and the first thing we're going to talk about is a cycle. And a cycle is from one point to an identical point. From one point to the next identical point on the wave. And I'm going to label some points. We'll call this one A, B, C, D, E, F, G for right now. And then I'm going to label this point way down here, H. All right. So one cycle is from one point to an identical point. So B, which is a crest, the high points we're going to call crests of the wave. So B to F is going to be one cycle. One crest to the next crest. I could also say from A to E, because they're the same height and kind of going in the same direction. So A to E, not A to C, because A is going up and C is going down. They're the same height but different directions. And I could also say from C to G is one cycle. All right, then the wavelength is the length for one cycle. The symbol for wavelength is the Greek letter lambda. Which kind of looks like an upside down Y. All right, and the unit is going to be meters. So for this example, I go from B to H, and I've labeled that that's 6 meters. And it's also, if I count cycles, B to F is one cycle, then to here I got a second cycle, and then all the way over to H I got 3 cycles. So it's 3 cycles. So if it's 6 meters per 3 cycles, the wavelength is going to be 2 meters. So the wavelength is just from there to there is one way to measure the wavelength. Frequency is how frequently the wave repeats. And it's going to be frequency. And we'll talk about the units in just a minute. So for this one, from B to H, I have 3 cycles in 5 seconds. So frequency is cycles per second. So that's going to be kind of our equation for finding frequency. And I get 3 cycles over 5 seconds is 0.6 cycles per second. And that's an appropriate unit, and I kind of like it because it tells you what it is. Okay, but sometimes you'll see this written as 0.6 hertz, abbreviated as Hz. So frequency is cycles per second. We can have a unit of cycles per second, or we can have a unit of hertz. It's the same thing. Period is the time for one repetition, or time for one cycle. And the symbol for it is going to be capital T. And the unit is going to be seconds per cycle. So for this one, the period is going to be 5 seconds over 3 cycles, which is going to be 1.6 repeating seconds per cycle. You'll notice that that's 1 over the period. It's the inverse, right? Or 1 over the frequency. The frequency was 3 over 5. The period is 5 over 3. So one equation that we're going to be using is that the period is 1 over the frequency. They're reciprocals. And we used that before when we were doing simple harmonic motion. The next thing is the amplitude. The amplitude is the height of the wave. Okay, it's the maximum distance from equilibrium. So if we were to label it on here, we would say that this right there is the amplitude. So over here we have the total height is 3 meters, but from the midpoint up would be half of that, so 1.5 meters. For this particular wave. And then the last thing we're going to be able to measure for our wave is the velocity, how fast the wave is moving. And our equation for velocity, and we're going to use this a lot, this is kind of like the F equals ma for waves, is that velocity is wavelength times frequency. For our particular example, the wavelength was 2 meters, and the frequency was 0.6 cycles per second, and I end up with a velocity of 1.2 meters per second.